Welcome back. In part 2, we are going to configure and verify routing information protocol version 2 routing. In part 2, we will configure RIPv2 routing on all routers in the network and then verify that the routing tables are updated correctly. After this RIPv2 has been verified, you will disable automatic summarization, configure a default route, and verify end-to-end connectivity. Coming to step 1, configure RIPv2 routing. Configure RIPv2 on R1 as the routing protocol and advertise the appropriate connected networks. So here we can see those commands what we have to configure on the router R1. Coming to the router R1, password is Cisco, enable password is class. Configure terminal. Here we have to give a router RIP and here the version 2. Here we can give passive interface, that is gigabit Ethernet 0/1, and here we have to specify the directly connected networks. Coming to our topology, here we can see those two networks. Here we can see one and here is the other one. Here we are going to give that information, that is 172.30.0.0. Also we got one more network, 10.0.0.0. We can see those directly connected networks using the command show IP route, and here we can see those networks. Here is one and here is the another. The passive interface command stops routing updates out the specified interface. This process prevents unnecessary routing traffic on the LAN. However, the network that the specified interface belongs to is still advertised in routing updates that are sent out across other interfaces. So here they talk about the use of this passive interface. Next is configure RIPv2 on R3 and use the network statement to add the appropriate connected networks and to prevent routing updates on the LAN interface. We will do this now. Now we will go to the router R3. Password is Cisco. Enable password is class. Here we will give the command show IP route so that we can see the network's details. And now we will give a configure terminal and router RIP. Here the version is 2. Also we have to give passive interface gigabit Ethernet 0/1, and now we have to specify the network. Here we can see those network. Here we can see the first one. We'll copy this address. Here is that, and the second network, here we can see that. Paste it here. Coming to C, configure RIPv2 on R2 and use the network statements to add the appropriate connected networks. Here do not advertise the 209.165.201.0 network. That means the interface G0/0. Here they given a note. It is not necessary to make the G0/0 interface passive on R2 because the network associated with this interface is not being advertised. Right, so we will do that. Coming to the router R2, and here we are not going to advertise this interface G0/0. Well, coming to password is Cisco. Enable password is class. Here we are going to give the show command, show IP route, and here we can see connected network details. Here we can also give better show IP route connected, and here we can see the details. Now configure terminal. Here we are going to give router RIP, then the version 2. Here no need to set the passive interface. We have to give the network. Here we can see that it's a 10 dot range. Both these interfaces, serial 0/0/0 and the serial 0/0/1 is in the A class, so we have to give only one network here, that is 10.0.0.0. And as specified, we are not going to advertise this network which is connected to this G0/0. Coming to step 2, examine the current state of the network. The status of the two serial links can quickly be verified using the show IP interface brief command on R2. Coming to R2, here we are going to give that show command. Show IP interface brief. And here we can see those interfaces. Status is up and protocol also up. Coming to B, check connectivity between PCs. From PCA, is it possible to ping PCB? Why? We will try that. First of all, we will get the IP address of PCB. Here is that. Coming to PCA, command prompt. We will ping to PCB. Here we can see a destination host unreachable. Why it's not pinging from this PCA to PCB? Coming to our documentation, here itself we have seen do not advertise the 209.165.201.0 network. That means this network. That's why this PCA is unable to ping to this PCB. Next is from PCA, is it possible to ping PCC, and to why? We will try that. First of all, we will get the IP address of PCC. Here is that. And coming to PCA, command prompt, and we will ping to PCC. Here is the IP address. Here also we are getting destination host unreachable. Request timed out, destination host unreachable. No, we are not getting the replay. So we will check the routing table of this R1. Password is Cisco. Enable password is class, and here we will give show IP route, and we will verify for that network. Here we cannot see that network, I mean this network, that is 172.30.30.3 network. That's why it is not communicating from PCA to PCC. Next is from PCC, is it possible to ping PCB? Why? Anyway, it is not going to work because same it is not advertising. So we will try that. We will get the IP address of PCB, and coming to PCC, command prompt, ping to PCB, destination host unreachable. We are not getting the replay. No. We are not getting the replay. And from PCC, is it possible to ping PCA? Why? It's not going to work, no doubt. So we will get the IP address of PCA. Ping to PCA, destination host unreachable. So we will check this network. Here we can see that network 172.30.10. network that we will check in this routing table. Enable password is class, and show IP route, and here we cannot see that network 172.30.10. network. That's why it is not sending. Now we will come to C, verify that our RIPv2 is running on the routers. You can use the debug IP, RIP, show IP protocols, and show running config commands to confirm that our RIPv2 is running. The show IP protocols command output for R1 is shown below. Here we can see that the routing protocol is RIP. Then we can see the version here. Also we can see automatic network summarization is in effect, and we can see routing for networks, all these. Also we can check in our packet tracer. Coming to R1, here we are going to give show IP protocols. Here we can see the output. The protocol is RIP. Also we can see the version here. Also the other details. Right. Next is when issuing the debug IP RIP command on R2, what information is provided that confirms RIPv2 is running? We will give this command. Password is Cisco, enable password is class. Here we are going to give a debug IP RIP, and we will wait for the output. Debugging is on. Here we can see we are getting some update. It's sending update, also it's a receiving update. That means RIP is working. Next is when you are finished observing the debugging outputs, issue the undebug all command at the privileged exit prompt. We will give that undebug all. So this debugging is turned off. Next is when issuing the show running command on R3, what information is provided that confirms RIPv2 is running? So coming to R3, here we are going to give as a show running config, and we will verify this RIP. We will check for the RIP. Here we can see router RIP version 2 passive interface. Also we can see the network details. Coming to D, examine the automatic summarization of routes. The LANs connected to R1 and R3 are composed of discontiguous networks. R2 displays two equal cost paths to the 172.30.0.0/60 network in the routing table. R2 displays only the major classful network address of 172.30.0.0 and does not display any of the subnets for this network. So here we can see show IP route output on this router R2. Coming to the router R2, and here we will give that command and we will check it, show IP route, and here we can see that here this R2 displays two equal cost paths to this network 172.30.0.0 network in the routing table. Also R2 displays only the major classful network address and does not display any of the subnets for this network. Next is R1 displays only its own subnet for the 172.30.10.0/24 network. R1 does not have a route for the 172.30.30.0/24 subnet on R3. That's why previously when we ping from PCA to PCC, it failed. So we will give this a show IP route command and we will check that. Coming to R1, password is Cisco, enable password is class, show IP route, and here we can see that. And again R3 only displays its own subnet for the 172.30.30.0/24 network. R3 does not have a route for the 172.30.10.0/24 subnets on R1. That's why previously this PCC unable to ping to PCA. We will check that. Coming to R3, and we will give this command to show IP route, and here we can see Next is use the debug IP RIP command on R2 to determine the routes received in the RIP updates from R3 and list them here. R3 is not sending any of the 172.30.0.0 subnets, only the summarized route of this network, including the subnet to mask. Therefore, the routing tables on R1 and R2 do not display the 172.30.0.0 subnets on R3. Coming to our packet tracer, the router R2, here we are going to password is Cisco, enable password is class. Here we are going to debug IP RIP, and we will see that. We'll give fast forward time so that we will receive that message. Here we can see a received version 2 update to 172.30.0.0/16. It's not received the subnets. Coming to step 3, disable automatic summarization. The no auto summary command is used to turn off automatic summarization in RIPv2. Disable auto summarization on all routers. The routers will no longer summarize routes at the major classful network boundaries. R1 is shown here as an example. So we have to go to router RIP and we have to give this command no auto summary. So coming to R1 CLI, password is class, configure terminal, router RIP, and here we are going to give no auto summary. Now we will go to R2 CLI, configure terminal, router RIP, and here we are going to give no auto summary. And coming to R3, password, configure terminal, router RIP, no auto summary. Coming to B, issue the clear IP route star command to clear the routing table. So here we can see that. First of all, we will give it on R1. Clear IP route, then star. Now we will go to R2. Clear IP route star, and coming to R3, clear IP route star. Coming to C, examine the routing tables. Remember that it will take some time to converge the routing tables after clearing them. The LAN subnets connected to R1 and R3 should now be included in all three routing tables. So we are going to give this command show IP route, and here itself they given the output. Here we can see that the networks. Also we can see show IP route command on R1. Here we can see the network details. Also on R3 show IP route. Here we can see that. We will verify all these informations on our packet tracer. First of all, we will check it on R2, and we can see these two networks. Show IP route, and we will check these. Here we can see the details. Here we can see those networks 10.0 and 30.0. Coming to R1, we have to get this network, that is 30.0. We will see that. Show IP route. Here we can see that. Also coming to R3, we have to get 10.0 0 network. Here we can see that. Coming to D, use the debug IP RIP command on R2 to examine the RIP updates. So debug IP RIP, after 60 seconds issue the no debug IP RIP command. So we will give that R2. Here we are going to give debug IP RIP. So here we can give fast forward so that no need to wait this 1 minute. Here we can see that. Now we are going to give undebug all. Here we can see what routes are in the RIP updates that are received from R3. We will check that. Coming to our output, here we can see that. Here we can see received version 2 updates from serial 0/0/1, and here we can see 172.30.30.0/24 1 hops. So here we can see that. Are the subnet mask included in the routing updates? Yes, it's included. We have seen there /24. Now we will come to step 4. Configure and redistribute a default route for internet access. Coming to A, from R2 create a static route to network 0.0.0.0 space 0.0.0.0 using the IP route command. This forwards any traffic with an unknown destination address to PC-B at 209.165.201.2, simulating the internet by setting a gateway of last resort on router R2. So this is the command what we have to give on this router R2. Coming to the router R2, configure terminal. Here we have to give IP route 0.0.0.0 space 0.0.0.0 space, then the forwarding router's address. Here is that. Coming to B, R2 will advertise a route to the other routers if the default information originate command is added to its RIP configuration. So here we can see that router RIP, then default information originate. So we will give this command. We have to go to RIP, and here we are going to give a default information originate. Coming to step 5, verify the routing configuration. View the routing table on R1 using this command show IP route, and here we can see these details. Coming to R1, here we can see that gateway of last resort. Also here we can see. How can you tell from the routing table that the subnetted network shared by R1 and R3 has a pathway for internet traffic? So here we can see, coming to R1, there is a gateway of last resort, and the default route, here we can see that shows up in the table as being lent via RIP. Same thing can be observed on R3 also, gateway of a last resort, and here we can see that default route. Coming to B, view the routing table on R2. How is the pathway for internet traffic provided in its routing table? Right, so we will see that. Coming to R2, and here we will give a show IP route, and here we can see the details. This router R2 is having a default static route 20.0.0.0 via here we can see that 209.165.201.2, and this is directly connected to the interface gigabit Ethernet 0/0. Coming to step 6, verify connectivity. Simulate sending traffic to the internet by pinging from PCA and PCC to this address, that is PCB. Where the ping successful, we will try that. First of all, we will come to PCA command prompt and we will ping to this PCB. Here we can see we are getting the replay. Now we will try from PCC to this PCB. Ping to PCB. Here we can see we are getting the replay. Next is verify that hosts within the subnetted network can reach each other by pinging between PCA and PCC. Where the ping successful, we will check that. We will get the IP address of PCC, and coming to PCA, ping to PCC. Here we can see we are getting the replay. Now we will try from PCC to PCA. Here we can see we are getting the replay. Here we have some reflection questions. Why would you turn off automatic summarization for RIPv2? Yes, so once we turn off this automatic summarization, the routers will no longer summarize routes at major classful network boundaries. Coming to the next question, how did R1 and R3 learn the pathway to the internet? Obviously, using RIP routing updates received from the router where the default route was configured. Well, that's all in this lab activity. In this video, we configured and verified RIPv2 routing. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share to your friends. And don't forget to subscribe this channel so that you will get latest uploading video info directly into your Gmail. Thank you.